Thank you very much. Hello, everybody. It's very nice to see you here. Welcome to our weather briefing. Markl has already introduced us. I'm Yasmin Markl, and my colleague will do the second part, Andreas Wirth. We both work for the Austrian National Weather Service, ZAMG. I will start with an overview about the present weather. So I have, okay, I hope you can see this. I have prepared this animation of water vapor, channel 6.2, and geopotential at 300 hectopascal, so pretty high level. And so we basically can see what's going on. This will repeat now. We have here this huge high pressure system over Greece that moves to the east, and then we have this little low pressure that comes over the Mediterranean towards the Alps. And I play it once again. Another huge system that comes from the Atlantic Sea and approaches Great Britain. So this was in the last days, and we have already got some comments. So quite rainy over Spain. Also, I think in England, some rain, and yeah, cloudy over many parts of Europe at the moment. Let's go ahead. This is the Dust RGB from today in the morning, or almost noon actually. So we see quite some clouds. We see many interesting structures. I want you now to take one of the markers and try to indicate the jet stream. And for this, wait 1 second, I even give you more hint, and you have already seen the animation of this streamlines, so it should be quite doable. And now just go ahead and, so yeah, we have already one guess. Very nice. Hard to see in this very colorful picture, but yes, okay, you have a really good eye for that. There is another branch of the jet stream. Maybe someone is okay. We have this over there that was maybe a bit more difficult. All right, yeah, okay. Now we have this blue line over Russia. That is actually the second part. I will. Okay, stop. That's fine. We have also here a very interesting guess. I will just show you the kind of solution now. This is where the jet stream was this morning, and yeah, so we have even someone has indicated this area here over Italy quite well. Someone has indicated this area. This is not the red color due to the jet stream. This is probably rather just very dry air. If you think back to the water vapor, we have seen that this is a very dark area, so probably it's just very dry air here. So next slide will show you the 24 hours microphysics RGB plus the radar. So you can see very nicely the big systems that we have here that cause some rain or snow. Also here over Spain and Portugal, we have heard that before. Jose, I think, has written from Spain, northern Spain. So yeah, we can also see quite nicely here. We have this big occlusion, a warm front, here some mixture of warm and cold fronts, and yeah, here's also the rest of warm and cold front over here. In this system, we have the occlusion here, and then the cold front, and maybe a little bit rest of warm front here. And another big system is here over Russia. Yeah, I think mainly we can see the occlusion and the cold front over there. All right. So we go on. Voila. Okay, this is the surface pressure map, where again you can see where the systems lie. Okay. Actually, now I want to jump to a case from the last days that was quite interesting. I will play this animation from Monday till Wednesday of the 24 hours microphysics RGB. And you can have a look. Maybe someone can already guess what I would like to show. I can already tell you it's something about clouds, about Lee clouds. I play it once more. So there are some quite nice structures, especially where we have higher mountain ranges. I give you a hint, maybe look at the Pyrenees here in Spain and France, then also look at the Alps, of course, and another nice example can be seen in Romania at the Carpathians, where also thick eyes of water clouds appear. You can see very well the structure of the mountains, and also you can see or identify the areas with low clouds, low stratus, or even fog. This is this very bright yellow color. Okay, so what I would like to show you in more detail now is the case of the Alps, where we had very nice foehn winds the last days. This is just to give you maybe a first feeling of how the wind was forecasted by the ECMWF model. This is again an animation over several days from Monday until today actually, and we can already see we have quite some high wind gusts here in the Alps, more than 100 kilometers per hour, and then on Wednesday was a bit weaker, and yeah, now Thursday comes, it gets more, and then Friday the more it's even more foehn winds here. So that's just about how high the wind approximately is. As I have said, this is a forecast, and now we will look at the observations in more detail. Okay, so for this I would like to show you the fog RGB. I like this very much because you can identify some cloud types and still you have very high resolution. Of course, you cannot see anything during night, but so this was, now comes Tuesday, and we have really nice clouds. Maybe you have seen that there are these waves north of the Alps. I'll play it once more. So this is Monday, not so much happens. You see quite nice the snow on the mountains, and then this is Tuesday with really nice stripes north of the Alps and also south of the Alps actually. I have this animation in a closer zoom for you, and I play it several times. So here you can really nicely see the zebra stripes that are north of the Alps and then move actually a bit away from the Alps, and there's another, looks like a denser clouds area that comes after. And in the south we have we have lower clouds, but there's also some nice structure inside. And now take a closer look to the eastern part of the Alps. If you look very closely, you can see that there's another structure that goes from more or less from north to south, and another wave pattern appears here. Maybe, I hope you can see it. I think I cannot put my pointer on the animation, but I play it once more. So just look closely at eastern Austria, so in the right-hand side of the picture, where you can see tiny stripes of Lee clouds. And I was trying to explain this phenomena a bit in detail. It was not so easy because it's difficult to distinguish between the cloud types and cloud height, especially because on top, as we maybe see in the beginning, or from time to time we see some bluish colors on top. So we have zeros on top, and it's almost impossible to identify the temperature by the infrared channels. So this was no option to identify temperature and then maybe the height of the cloud, because I was interested if this denser cloud area is above the outer clouds, the zebra clouds, or it just comes after them. So what I was firstly looking at was the wind pattern in different levels, and I have found out that at 8 UTC at 900 hectopascals, so quite close to the quite lower level, we have this southerly winds that perfectly fit to this wind patterns, this waves over there. And then a bit later, at 1:30 UTC, at 700 hectopascals, so a bit higher, there is this southwesterly wind that perfectly, again, fits to this drive that comes here from the north to the south, more or less. So here you can see it maybe a bit better. So, and to explain, maybe again, why it was so difficult to identify temperature by the infrared channel, here you can see the cloud type SAF, Satellite Application Facility, that shows that over this huge area there was semi-transparent thick cloud layer mixed with very high dense clouds. So that was the problem with that. Okay, and I still found another way to have a closer look and to distinguish between the two cloud types or the two cloud areas by looking at the convection RGB, which is not so typical for this time of the year, but here it helps very well. I will first show you, and probably you can already see a difference. So you can see that the clouds that is denser and more in the south is brighter, also has more yellow color, and the other part, the wavy structure, is more orange. And this is obviously because there are smaller ice crystals. So the convection RGB looks for the very small ice crystals that are brighter, more yellow, and this is why here we can say that the denser clouds in the south probably are most likely are ice crystals, therefore also cannot so easily build this wave structure, and also is more or less just a different kind of cloud. Okay, let's look at some results of this event. One is I have observed on my way to work, and I made this little video here of the sky because it was incredibly red, golden. So I was really stunned by this sky. And here in I'm looking to the south, and here you see very nicely this gap of the clouds. So in the south there was this gap, and in the north there were denser clouds, and then eventually this wave pattern. Okay. And also, some measurements. So we had on the mountains wind speeds of 156 kilometers. But also if you look at lower areas, we had 100 kilometers at almost 400 meters, and also in lower areas, 85, 83, around 80, 70 kilometers per hour. Also temperatures were incredibly high for this time of the year, and we had some records. 21 degrees were measured in Vorarlberg, in the very western part of Austria, and many measurement stations had 19 to 20 degrees, or many, but quite a lot. Okay, so another short slide I want to show you, because this is a very nice example of a foehn case. This is here a little bit south of Salzburg in Golling, at almost 500 meters, where we have really dry air due to the foehn, almost 19 degrees, 18.5 degrees at noon, and also wind speeds at around 80 kilometers per hour. It's a really nice case here, and especially this very dry air. All right, so this was it for the first part. Now I will pass the presenter's rights to Andreas, and I will hear you in the end again. Thanks so far.
Thank you, Yasmin. Now it's my part. Hello, I'm Andreas Wirth from ZAMG in Vienna, and I'm going to talk a little bit about RGBs, and we will also move away from Europe. We will go to another region. This is what I saw last week: United States, Canada, so North America, and it was striking me because of the intense red color on the Dust RGB. That's what you can see here, the Dust RGB. So please take your pens and mark the frontiers between warm and cold air. Just as a guess, what do you think? Where is the warm air? Where is the cold air? Just draw a line exactly. While I think it's not too difficult. Yes. Yes. V or U shaped. Exactly. Very, very easy, I think. This is a nice trough over northern part of America. So you have seen the temperatures. I think it's a bit small, but you see that the temperatures are really low. Maybe I can take a pointer. Is this my pointer? Yes, you have here minus 27 degrees, and even below minus 30, minus 36 degrees. So we have here in this area, which is marked in red, in the Dust RGB, is very dry, cold air coming from the north in the region behind the trough. So the air is coming from here. Oh, what a pity! It's red. Red on red is not so fine. So here, this is the cold air coming from the north to the south and reaching the central parts of the United States. Even here we have minus 7 degrees. I don't know if it's normal for this time of the year, but minus 30 degrees is for sure not normal. Yes, why is it so interestingly, so strikingly red? That's what I was wondering. This is the Dust RGB. I followed this is produced with the common recipe of the Dust RGB. And if I click once more, yes, here you have the temperature chart. So this confirms what you have written, what you have drawn on your page. So back to the question, why is it so intensely red? This red color in the Dust RGB, I seldom saw it in Europe. So you see here, this is from yesterday. It's also quite cold here over the Scandinavia with minus 18, minus 13 degrees, no clouds. But it's not that intensely red. It's more, you see, in fact, I go back. I forgot to mention something because I took the color selector, and you can see the three different types of colors: the RGB, red, green, blue. And you see, if you point here, it's 180. The value is 180 for red, and for green and blue it's 0. So there's no contribution from the other channels. There's just the red channel who contributes. But here you would expect the same intense red color because it's cloud-free. There are some clouds here, but only minor. Most of the parts are cloud-free, and you would expect also very intense red color, but in fact there isn't. So the Dust RGB from MSG is not that intensely red as it is from GOES satellite, because you see here 176, which is quite similar to 180, but we have another green, quite a high green intensity. Why is that? The reason is quite simple. We have here the recipe. It's a bit okay. It went out of the line, but you can see it. You can see that the recipe for red is the same for GOES AB sensor and for the MSG sensor. It's not different. So I clear my annotation so you can see again the values -4 to 2 degree, -4. So the red cannot be the reason. There is the same intensity in both RGBs. The difference seems to be here from the green channel. For the AB sensor, the limit is 0 to 10 degrees. That's the sector which is taken for the green beam. And for MSG severe sensor, it's 0 to 5. So we have a higher intensity from the green channel when we take the Dust RGB than for the GOES sensor when you take the Dust RGB. The blue again is similar. So I just calculated both images with the recipes as they are provided and as they are used, and you see the differences. And in my eyes, the AB sensor with the 0 to 10 is a little bit nicer than the 0 to 15. Maybe one should compare it even more and think about modifying a little bit the Dust RGB recipe for severe sensor. So this is just the explanation for the difference. Another difference, I come to that later. I will show another difference. There's another effect which was quite nice to observe, the lake effect snow. This happens, here is the snow and ice RGB, it's not a Dust RGB anymore. You have small cumulus clouds that are produced over the lake because the water over the lake is warm. The wind arrives from the northwest, and strikes over the sea and produces cumulus clouds. And in the lee of the lake, you often have snowfall. So that's what is described in this small text. You have a local influence of the lake in very cold conditions, but the water lake temperature must still be warm so that you have enough evaporation, and this produces some snow. So for the same synoptic situation, I took the air mass RGB, and you see that here we have this intense green color over the cold area. And usually the green area is in the south. That characterizes the tropical air mass. But here, in fact, instead of having reddish or bluish air mass, we have also a green air mass. And if you look at the color selector here, you see that the green part is 163, and here it's only 88. So this region here seems greener by the eye, but in fact the green intensity here in the northern part is even stronger. But we have an even stronger red part here that makes the green not look as greenish as in the southern part. So why is that? We have here the recipe again. The red color beam is the difference from the water vapor imagery 6.2 and 7.3. And as I told you before, this is a very dry. I take my pointer again so you see where I'm pointing. No, this is the wrong one here. So this is a very dry area. Both channels show, if you look at them by themselves, very dark area, and the temperatures must be very similar. So we are near the 0 degree difference that makes a very high intensity. While here, this is a very warmer region with more humidity, and then the difference is larger in the negative direction, and therefore less red contribution. And for the green, we have a very interesting effect. Usually the green channel is the difference with the ozone absorption, the IR 9.7. This is the ozone absorption, which is usually quite weak in the tropical air mass because there's not much ozone. That means there's a bigger difference in the in the northern part, we have, of course, a higher ozone absorption, but we have also the surface inversion. That means the surface is very cold, the air above is a little bit warmer, but since we start with very, very low radiation from the surface in the 10.8 micrometer, the ozone absorption from 9.7 is shows nearly the same temperature, because the surface temperature is similar to the temperature at level where the ozone absorption is very high. So we have a range around 0, and that makes the high green part. So this is a very rare case where we have no humidity in the air, still ozone absorption, and very green, very intense green color beam because of the cold surface inversion. Usually the green part is found in the southern part where we have the tropical air. So this is quite interesting. Why do we have this surface trough? You showed it here. It's this trough region. There is a nice explanation I found on YouTube. They posted a seasonal weather forecast. You can watch it. It's not very long. And the meteorologist here in this video claims that responsible is this warm anomaly over the sea. So we have warm air here south of Alaska, and then the air is moving around this and producing this trough. This is the reason for having a trough over Central America. And here you have, I don't know if you remember, I think 2 years ago you have the polar vortex, which sometimes moves to the south and brings very cold air to Northern America. By the way, the second link is also quite interesting. You have the monthly sea surface temperature anomalies. The chart that is plotted here for November. You can go back until, I think, September 1981 and see the monthly temperature anomaly. And I would really recommend to you to look at it, because it's very revealing how the sea surface temperature is getting warmer in the last decade. 2 weather briefings ago, Markl was referring to these new RGB types, which will be available from MTG. This is the cloud phase, and this is the cloud type RGB. Both uses new channels, the 2.2 micrometer and the 0.3 micrometer, 1.3 micrometer. They will be available on MTG, but they are already available on the AB sensor from GO 16. Unfortunately, the 1.3 micrometer channel is not available on Huawei. So I was looking a little bit closer to the cloud phase RGB, just to show you again an example I found. The bluish colors mark the small and large ice crystals, while the white and pinkish areas here mark the small and large water droplets. So much for the cloud phase RGB, which is produced thanks to the 2.2 micrometer channel. I was looking over the Asian Pacific region, and I discovered some green dots. So my question is, what are these green dots? And if I tell you where they are, then it's not so difficult anymore. So I let you guess. Yes, correct. Fire is correct. So the second question is, where is this? Maybe you have heard it in the news. It's all over the news at the moment. What is this land here? Any guess? Yes, this is Australia, exactly. This is Australia. This is the east coast of Australia. And while I was looking for cloud phase RGB, I was discovering this green dots. And this green dots is clearly coming from the fire. So I was wondering, is it possible, and why is it possible to detect also fire? So in this case, it's bushfire from the cloud phase RGB. So first I had to confirm that this is really fire, and it's quite easy. You go to the internet and you go to the crisis map of Australia, and you see where the bushfires are at the moment, and if you click on each of these triangles or squares, you get an information about the actual status of the fire, which is quite good and quite interesting. So this confirms that here we have some fire in the eastern part of Australia, but still the question is, why do we see it in the cloud phase RGB? And here you see the recipe of the fire temperature RGB. I'm not talking about this one, but the fire temperature RGB is used to detect fire, and it also uses, as you can see here, the 2.2 micrometer channel from either from EUMeTrain or from GOES. They are on both satellites, and they will be available also on MTG. And you see the green channel is small ice water particles, so it has a double use. It can be used for detecting the difference between ice and water, but it can also be used for fire detection. And if you want to know more about the fire temperature recipe or the fire temperature RGB, then go to this resource here. There's a nice quick guide which explains you how this works, but this is not the topic of this weather briefing. So thank you very much. These were a few considerations regarding the RGBs, and sorry I had to speak very fast because now it's back. I'm giving back to Yasmin with our Christmas weather. Thank you.
Thank you very much. Can you pass me the presenter's rights, please? Thank you. Okay, I'm back again, and as Andreas has already announced, I will have a look together with you at the Christmas weather, so weather for next week, because in Austria it's always the question, will it be a white Christmas or the green Christmas tree? So I have quickly prepared this animation of the geopotential. It starts at Tuesday again, so this is today now, and then you see this outbreak from the north that brings again colder air, a cold front on Saturday, and then eventually again colder air that might actually split off and move more to the southeast. So yeah, doesn't look too good, neither for white Christmas nor for sunny Christmas, at least in Middle Europe, but I will quickly go through this animation. Here we have geopotential, equivalent potential temperature, wind gusts, precipitation, the snow line and clouds. And yeah, so you can see starting from today. Okay, we have then on Saturday the cold front passing by the Alps, and generally then really colder, much colder air in Middle Europe, while actually Spain and Western Mediterranean area have favorable conditions with probably dry weather. Also, if you look at the precipitation map, I will jump now to the 24th of December. Okay, so you see quite dry conditions in Spain, Portugal, parts of Italy, parts of France, also in the Balkans, but yeah, Germany, Austria, many parts of Europe will get rather changeable conditions with not too cold temperatures, so it will be difficult to get snow in the lowland areas. Yeah, so probably also quite windy conditions. Yeah, we can see next year if we get another white Christmas tree then. Anyway, no matter how Christmas will end up, white, green, or different, we wish you a very Merry Christmas and also Happy New Year, of course, and thanks for listening today.